All right, so just going over the rules for integration. So we started doing integration. That was our last bit we're going on. And so just pausing here, and we're going to do a bit of a revision here of, we've got all our rules for derivatives. Now, this is handy here because we've done this, we've pretty much locked this down. And these rules here, if we know the derivative of a function, then the integral is just the function before the derivative. So if we look at this first one here, mx plus c, so this is just a linear function. If we took the derivative of this, we would get m is that value. Now, let me just change a color because I'll highlight these sort of as we go. So over here, we've got, if we have a constant there and we take the integral of it, then the step back, the antiderivative of it is that constant times x. Plus an arbitrary constant, k, which is our real number there. So these rules here link to the rules next to it. So I'm not going to spend too much time here. We need to write these out, but realistically, you look here, same as this x to the n, realistically, we see this step back here. So if I was to take the derivative of this function here, I would get x to the n. If I was to take the derivative of e to the x, I would get e to the x. All right. 1 over x, if I take the integral of that, I get ln x because ln x has a derivative of that. So the rules are all there. All the rules that we've got here, or combinations of them, allow us to differentiate all functions covered in this course. These bottom ones here, there's no equivalent rule for them. So what we usually do is we'll expand or divide first and then do our integration. We should always check our integration answer by differentiating. So let's go into an example now. So we've got here, example, find the integral of x cubed minus 2x squared plus 5 with respect to x. And so what we do here is, now in our text, they don't actually do it this way. I'm just going to I'll only do this for the first one, and then we'll sort of skip this step. But one of our rules was that we could break this into individual integrals. And so a lot of the time we can actually think of these things with our rules in terms of individual parts. So here we've got, well, x cubed, what would give me x cubed? I would have, that's got to be x to the 4, and then it's going to be 1 over 4. Now, if we look back at our rule here, this is the equivalent of the integral. If I have a power, it's going to be n plus 1 in the power and over n plus 1. So here we've got n plus 1, so n was 3, so n plus 1 is 4, 1 over 4. Our next one here is going to be take 2, so that's our constant there. I'm just going to leave that out the front. And then we're going to have n plus 1, n being 2, this is going to be x to the 3 all over 3. Or maybe I'll write it in the notation we've done. It doesn't really matter. That would be 1 over 3 like that. And then plus 5 is just a constant, so it becomes 5x. And then we've got a plus c, and we want to specify that c is a real number because that's what it is. And so let's just clean this up a little bit so the notation's a bit better. We got x on 4 over x to the power of 4 on 4 minus 2x cubed all on 3 plus 5x plus c. C is a real number. Usually I write that once in a solution. It's good to have, and I'm just going to delete it from here because it's going to get in the way of the next bit. All right, cool. So next bit here, we could split these up, but we know that we can do that now. So our first step for this particular one is we want to write this integral with everything as a power. So similar to how we did in integration, we've got x to the negative 3 and x to the half, and this is all with respect to dx. So now I go into the next line. N plus 1 is, when n is negative 3, if I have plus 1, I'm going to have negative 2, and then it's going to be 1 over negative 2 there. All right, and then we've got take x to the half plus 1 is going to be x to the 3 on 2, and I've also got 1 over 3 on 2 here. Now, simplify this out. It's going to be, I should is going to be equal to negative. Now I'm moving this negative up to the top just because it makes it easier. Negative 1 over 2x squared. I've moved that to the bottom. And then minus, you got to remember here that we've got this 1 divided by 3 on 2. That's the same as 1 times 2 on 3. With our fractions, we can multiply and put them up the other way. So negative 2 on 3. And then I'm going to have x root x. And that is my solution. I've missed my c, so I would drop a mark there. So c is a real number, and then plus c. We always need that constant unless we know the exact value of our function. Now in the text, it looks like they don't change back to this form. They leave it as 3 on 2. So I would prefer this form if I was going to substitute it, or I would prefer this form if I was going to integrate again. Okay, next one here. So we're looking at the integral of, now I'm going to write this here because this 2 sine x, this first one, is sort of the integral of 2 sine x like that. It just makes this next bit a bit easier, or there's a constant out the front. We're just taking the integral of it. Maybe I'll do it like so. So the 2 is there, and then the integral of sine x, we're going to go up to our rules. What do we got? So sine x gives me a negative cosine x, so I'll come back down. And so the integral of that is negative cosine x. All right. And then I've got negative 1 here, and then the integral of cosine x is just sine x. We sort of know that from like the derivative of sine and cosine. So then we're going to write this out a little bit more simply. So negative 2 cosine x, take sine x plus c. Cool. So they're sort of our simple integrals. So we're going to go on to the next one. So these ones are the product and quotient rules. So you got to assume when we did derivatives previously, we would have applied like a chain rule to this one here. But for integrals, we don't actually have those rules. So we've got to expand this out. So it's going to be the integral of 3x times 3x. So I'm doing this like a FOIL expansion. So first term is going to be 3x times 3x. So it's going to be 9x squared. And then my outers is going to be 3x times 2 on x, which is going to give me, I'm going to write this out properly, unlike the text has done. So this will be 6x over x plus 6x over x. So you'll notice that they will cancel. That's outer and inner. And then my final term here is going to be plus 2 over x squared. And that's dx. So one more line, we got 9x squared plus 12. Oh, I missed that. 2 times 2 is 4. Okay, plus 4x to the negative 2 dx. Now this is a simple integral like we've done previously. So 9x squared is going to be 1 over 3x to the cube, because the power, you got to remember we add 1 to the power that goes there and there. Okay, plus, close bracket, plus 12x, and then plus 4x to the negative 1 over negative 1 there. Okay, and plus c. C is a real number. Now I'm going to simplify that out. This will be 3x cubed, because 9 times a third. 3x cubed plus 12x minus 4 over x plus c. Cool, that one's done. Let's jump to our next one here. So we've got, obviously this one's a quotient, so let's break this out. So I've got the integral, that is not good, dx. So let's quickly go. Trying to rush through these to not make it take too long. So this one here, we're going to have x squared over root x minus 2 over root x dx. So my next step here is I'm going to want to write these a little bit with just powers, so like a single variable, so I don't have to think about a rule. So x squared, this first term is going to be x squared minus a half, and this other term will be negative 2x to the negative 1/2, and that's to the dx. So my next line here, the integral of x, it's going to be 3 on 2 minus 2x to the negative 1/2 dx. So with respect to x, so let's do the integral now. So we're going to add 1 to this. So 1 over, it's going to end up being 5 on 2, x to the 5 on 2, minus 2, and then it's going to be x to the half. So it's going to be 1 over a half, and that's going to be x to the half there as well, and then plus c. So let's clean this all up. So this the coefficient here is going to give me 2 over 5 x. Now that's going to be squared and square rooted, so that the squared gives me 4 on 2, and then it's to the half, and then I've got minus 4 here because this half, so 1 divided by half is the same as 1 times 2. So that would be 2 times negative 2 gives me negative 4 x square root x plus c. All right, cool. We're rolling through these not long now. So now we've got this different question where it's find d dx of this and hence determine our derivative, so our integral of x cosine x dx. So this is where we look at if we can take the derivative of something, we can consider what the integral of it would be. So the derivative of, so d dx of x sine x is a product rule. So we do our, so I'll just put this here. Let's do a different color. I'm just gonna u v, which means we're going to be looking at u dash v plus u v dash, just to help ourselves out. So u dash here is x, or u is x, so the derivative of x is 1. Okay, and then we've got sine x, so 1 times sine x, I'll just put a bracket around the 1, plus x, and then we've got the derivative of sine x is cosine x. All right, so it doesn't cause me any issues because I don't need a negative sign, so cosine x, sweet. So what this means here, if I clean this up, equals sine x plus x cosine x, means I can now go, well, the integral of sine x plus x cosine x with respect to dx, I missed a c here, plus c, is going to equal this value up here. So this side of it here is this side, and then we're going to have x sine x is going to give me what this integral equals, so x sine x. Now, this is close, but we'll notice here that we're trying to find part of the integral. We're only needing this bit here. So we're going to go, well, the integral of sine x dx plus the integral of x cosine x dx equals x sine x. Okay, so we've got that there. Now, sorry, I did miss this. This could be c. We could have another value in there, so plus c, I should have had that there. This bit here, because it's a derivative, definitely does not have a c, so I've made a little error there. Okay, let's re-highlight that. Okay, so the x sine x. Now, the integral of sine x is cosine x, negative cosine x. Let's just double check our rules again. So go back up. What have we got? The integral of sine x is negative cosine x. So I'm going to put that in here. So negative cosine x plus the integral of x cosine x dx. Now, even though I've done this as an integral here, because I've got this constant over here, we don't know what this constant is. Realistically, it's just a constant added to the function. Until we figure out what it is, we can just leave it there. So this equals x sine x plus c. So now my final step is to add cosine x to both sides. So I'm going to have the integral of x cosine x dx equals x sine x plus cosine x plus c. All right, sorry, I know this has been long, but I've got one final one to quickly go through. So this one here, find f of x given that. Now this is where we find what our constant c is, and this helps us find equations, particularly kinematics. This is handy for. So we'll just quickly roll through this. So it says find f of x given that f dash of x equals x cubed minus x squared plus 3. So the integral of f dash of x dx is going to equal f of x. All right, so in this space here, we're going to go, well, the integral of x cubed minus 2x squared plus 3 dx equals f of x. Therefore, f of x is going to equal x to the 4 over 4. So that's the integral of this first term minus 2x to the 3 over 3. Okay, and then the integral of 3 is plus 3x. And then plus c, a constant. So we've got our function now. We're also given f of 0 equals 2. Therefore, 0 to the power of 4 over 4 minus 2 times 0 cubed over 3 plus 3 times 0 plus c equals 2. Therefore, c equals 2, and our function f of x, so therefore f of x equals x to the power of 4 over 4 minus 2x cubed over 3 plus 3x plus 2. Cool, one last one to do and then we're done. All right, so I'm going to skip this first step. So we're looking at f of x is going to be the integral of this term, which is 2 sine x minus x to the half with respect to x. Cool, so this is going to mean that it equals the derivative of sine x is negative cosine x, so 2 negative cosine x. All right, then we got minus x to the 3 on 2 over 1 3 on 2 plus our c value, so we've got equals negative 2 cosine x minus 2 on 3 x root x plus c, where c is a real number. We've also been given f of 0 equals 4, so this is f of x. F of 0 equals 4, therefore negative 2 cosine 0 minus 2 on 3 0 root 0 plus c equals 4. Now cosine 0 equals 1, so negative 2 times 1 minus this whole thing here is going to multiply to give us 0. Minus 0 plus c equals 4. So negative 2, if I add 2 to both sides, I get c equals 6. So my f of x, so therefore f of x equals negative 2 cosine x minus 2 on 3 x root x plus 6. All right, lots of examples there. We've done well. All right, thanks guys.